So I've been given a big challenge. And that big challenge is to attempt to condense about 3 or 4 years of course study into about 15 minutes. Or at least do enough, condense it enough, or perhaps maybe in a way that when you leave you're a little less confused than you are now, or know at least enough knowledge that you understand some of the basic understandings of climate change. So when we met as a group, one of the first things I was asked to do is they wanted me to give somehow a little bit of an update of where we are. And so this was a fairly recent article that you see up here. I know it might be hard to read because the screen's kind of tiny, but it's speaking to the mass extinctions that are occurring right now, primarily related to climate change, or if you will, global warming. Right now, extinctions are occurring at anywhere from at least 100 times to as much as 1,000 times faster than the normal rate, perhaps even more. So that's kind of the big picture as far as it goes for the biosphere, the living part of our Earth. We're one of those creatures. So oftentimes, sometimes depending on what crowd I'm in, and people are going around the room and introducing themselves, and people are saying, oh, I'm a nutmegger, or I'm an American, sometimes I'll say I'm an Earthling. And a lot of people look at me weird, and I truly kind of believe that until we break out from the categories we like to keep ourselves in and realize we're just one of many living creatures, we're not going to make the big change that we need to make on this issue. Because we get too caught up on just the human perspectives of what we need. And right now, in this current time of society in America, the number one thing most people are worried about and concerned about, understandably, is money. Where's my, living paycheck to paycheck, a lot of people, 2, 3 jobs. So the first thing I was asked to do was to speak a little bit about the differences between weather and climate. So everyone do their homework? I know somebody, the science teacher knows the answer to this. So I'm going to ask him not to answer it, because he knows. But what's the difference between weather and climate? Does anyone know? So weather is more short term, right? And it's about precipitation, rain, snow, and temperatures and how they change in a particular small area of the earth. And it's short term, usually no more than a week, right? So that's weather. Whereas climate is still kind of about weather. It's about precipitation. It's about temperature. But it's about more. It's also about wind patterns, wind speed, and more importantly, it's long term. And perhaps even more importantly, it's generally much more bigger regionally than weather. At the very least, you're talking about climate regions. So this is just kind of a synopsis of the major groupings of climate regions. There's many more. There's about 3 times more subregions, if you will. And there's a whole classification system, and obviously I don't have time to go over all of them tonight. I do invite you to come take my climatology class if you wanted to learn about them. So the next thing I was asked to do is to please help clarify the difference between these 2 terms that you see up on the screen right now. Climate change and global warming. So there's a lot of politics being made about climate change and global warming. And one of the things that happens right now is there's this accusation, that all of us scientists are first off making millions of dollars off of this. Hey, where's my paycheck? Right? I'm not getting paid tonight for this. And the other part is that, hey, they started using this term climate change because the words global warming weren't effective. So they changed it. We proved global warming wasn't real. Well, of course that's not true. It is indeed getting warmer pretty much just about from year to year right now. This year was warmer than last year. Last year was warmer than the previous year, and the year before that, and the year before that. Right? Nearly all of the top 20 warmest years have occurred since the year 2000. All but one. And that one was 1998. So it's indeed getting very warm and quickly. So that's what climate change was originally about. So climate change is about the overall trends of climate, and it's not just temperature. So climate change is not even just about it getting hotter all the time, because the Earth's climate's been changing for years, millions of years, billions of years. Heck, there was a time when the Earth was like a giant snowball at one point. The entire Earth was under miles of ice. And then it warmed up, and the glaciers retreated, and then it cooled down, and they grew a little again, and then they kept going up and down, up and down. There's many reasons why that happens, and I definitely don't have enough time to get into all that tonight. But if you're interested into some of the main reasons that have absolutely nothing to do with humans, I'd urge you to look up the Milankovitch cycles and sunspots, and you'll learn a little bit about the Earth-Sun relationships that have impacted global warming and climate change. So global warming, though, refers just simply to the Earth's rising temperature. That's it. It's about the temperature rising as a result, one of the symptoms, if you will, of the climate changing. There's other symptoms, but right now what's going on is this symptom, the warming, is creating more symptoms. So it's like when you don't deal with an illness that's small, and you got maybe something going on, and mom says, hey, drink lots of liquids, go to bed, get rest, and you don't, and you ignore her. And then all of a sudden, now not only do you got a fever, then you got a sore throat, because you didn't pay attention to the symptom. You didn't do what you need to do to fix that symptom, and now more are around. So that's what global warming is about. It's one symptom of the much bigger problem of climate change, which is being caused and induced by humans. Right, so right now we are warming. Our planet, our entire planet is warming. So just to be clear, that does not mean that every point on the Earth is hotter today than it was 10 years ago. When we talk about global warming, it's the average temperature of thousands of points of measurement around the entire globe, averaged out. So when you do that from year to year or decade to decade, the average global temperature is warmer. Now, another thing that you may not know, how are we doing on time? Good. Is that a lot of people think warming and cooling occurs at the same rate regardless of where you're at on the Earth, and that's not true. So one of the interesting things that I point out in my class that students usually are surprised to learn is if you were to get 1 degree of warming at the equator, at the North and the South Pole, you could get up to about 14 degrees of warming. So the poles are warming at a much faster rate than the mid-latitudes or near the equator, much faster. And that's one of the reasons why you're hearing scientists, climate scientists in particular, having a lot of concern about the North and the South Pole, the Arctic and Antarctica and Greenland. So I'm going to skip through some of this because, like I said, I know I don't have time to get through all this. There's tons of good information that helps explain some of the history of the science. It's not a new concept, by the way. There's been scientists studying climate change, researching climate change since back in the 1700s. In fact, the first guy to ever get a Nobel Peace Prize was not Al Gore. It was a gentleman back in the 1800s, Arrhenius, and he got the first Nobel Peace Prize for realizing humans' activities had the potential to cause warming of the entire Earth because of the emissions of carbon dioxide. So this was early on into the Industrial Revolution. So there you can see, right? The Earth's been cooling and warming, and I can promise you that humans had nothing to do with it getting that hot back then, because we weren't here. Right? So we've only been around here a small little tick on the clock of time. Basically, a dot, where that red dot is if I could keep my hand steady. That's present. And if we were to research it, the guy earlier in the screen talked about some of this, so I'm going to kind of cruise through a lot of this quickly because hopefully you heard what he had to say. It's not volcanoes. It just simply isn't happening quick enough. In fact, that's more recent data for you on volcanoes. right now about 0.26 gigatons per year versus humans at 35. So it's definitely not the volcanoes. Sunspots do indeed impact things, but it's not just them that changes the climate, especially for a sustained trend. Someday you can invite me and I'll go over all this with you. So when you look at all the Earth-Sun relationships, one thing becomes very, very clear. The Earth-Sun relationships that are constantly in fluctuation on a cycle, each one has its own cycle of time, indicate we should indeed actually be cooling right now. We should be experiencing a slow, steady cooling. Instead, we're warming. In fact, we're warming at rates where it would normally take the Earth 10,000 or 100,000 years to warm up what we're doing in less than 10. So the rate is much accelerated. So this is all about Earth-Sun relationships. Once again, I know we don't have time, so I'll cruise on through. You heard the gentleman talk about the greenhouse effect already and how we contribute. So here's a little piece of the science that also typically the public doesn't get to learn about. So you hear about these greenhouse gases, and particularly you hear about carbon dioxide. Right, of course, we all spewed a little, well, most of us driving here spewed out a little bit of carbon dioxide, right, out the tailpipe of our car. Or we heat with coal or gas, natural gas or oil. And when we burn those, we're putting up carbon dioxide. But we aren't necessarily the problem alone on that. And important to understand is that carbon dioxide, once it gets spewed up into the atmosphere, it's going to stay up there for about 1,000 years. In order for it to cycle through all the Earth's systems, it takes about 1,000 years. So what that basically means is we could shut down all CO2 emissions today, and we're bought into 1,000 years worth of what's already up there, what we've already put up. Now, we're concerned about that, and the reason you hear about carbon dioxide mostly in the news or from scientists like myself when we speak to the public is because that's the one we have the most control over. We have very much direct control over whether or not carbon dioxide is getting emitted into the atmosphere at unnormal rates. Our cars, how we heat, industry, etc. Another one is methane. Is that the 5 or 10? The other one is methane. And methane, once it gets up into the atmosphere, it stays up there for about 100 years, a little over normally. But here's the thing. So it's not up there thousands of years like carbon dioxide. It's only roughly, say, 100 years or so. But it's up to as much as 86 times more of an efficient greenhouse gas than carbon dioxide. So this is what that means. For every one little molecule of methane we put up into the atmosphere, it's equal to anywhere from 26 to 86 molecules of carbon dioxide. Right, so it's great that it doesn't stay up there as long, but it's much more efficient. So, but here's the thing. What are you guys doing that emits methane? At massive amounts. Huh? Well, that's indirect. So you have your primary footprint and you have your secondary footprint. And one of the primary footprints is related to your food, which is a secondary footprint because most people aren't raising their own cows and making burgers. Right? You usually go buy it somewhere. So that's kind of a secondary footprint. That's about it. And that's a minor part of the methane going up right now. Most of it's going up from the bogs, from wetlands, from the bottoms of the ocean, and a lot of it is encased in the glaciers and in the permafrost. And so once those glaciers began to melt at an unnormal rate, we started to release something we can't control. We can't refreeze the glaciers. And so now those rates are going drastically higher. What, I have about 5? I told you she challenged me. I'll see if I can live up to it here. So here's what's happening in the Arctic. So this is a report by the Intergovernmental Panel on Climate Change. And what you see in the gray areas is if we were to do nothing, just keep doing what we have been doing for decades and decades, the Arctic is going to melt, they were saying, by about 2070. There'd be no ice in the North Pole. Zero in the summer. It would just melt all away. So I took it up, I was curious about this. So I took and I started to plot what we have been measuring, not projecting, but actually measuring where we're at. And what I found out is we were there in 07. We were there in 2012. By 2018, we were there. So if we follow that trend line, and I know it's a short level of time, but we're not headed in the right direction by no means. And now scientists are coming to realize that the methane releases that they thought were happening, that it's probably happening at least 10 times the rate, if not more than 100 to 1,000 times more. There's a lot more methane being released. The calfates are at a much higher volume, especially at the bottoms of the oceans. So
that seems like a great point to pause.
yeah, so we're likely to wake up by around 2030 and turn on the weather guy or girl or woman or person and find out there's no ice. It's very likely to happen now within my lifetime, which when I began to lecture about this, I used to say it never happened in my lifetime, but it might happen in my students' grandkids' lifetime. And now we know it's probably going to be ours. So I'll stop there for now. I have a lot more science to share, but I don't want to eat up all your time. Thank you.